Good evening to everyone. I'm Alessandro. I'm the Academy Manager of Festo Academy in Italy, and I'm very happy to be here to talk about people, skills and talent, since I had the chance to listen a lot of presentation about investment in equipment, investment in technology, R&D design, but how much we will invest in our people and talent development. So, a few words about Festo. We are a German group, an automation group, a medium multinational because 3 billion and 20,000 people, but I'm from the right side, the education one. The group developed 30 years ago another sister company that is focused on consulting and training. We had a long relation and collaboration with the dual system in Germany, with the Fraunhofer, with all this kind of institution, with the World Bank to develop the countries. And our main business in the education business is sometimes with the institution, the global institution, to work for people development in a larger sense, if you want, and with the consulting, with the enterprise, industrial enterprise for consulting and training. So these are the two main streams in the education part. So we just introduced this kind of topics. We will need really millions of new jobs by 2030. Especially, in the mobility sector industry, but also we have a strong relation with Industry 4.0. Festo is one of the partner in the steering committee of German Industry 4.0, and we had the chance to face this kind of problems in the last 10 years. So there are a lot of global politics in Europe that are trying to prepare this new challenge for the talent that in Italy we are not so ready to face in this moment. We are struggling to prepare this kind of people, but we are not successful till now. So there are new technologies. You imagine for years we had requests from companies to help them to change mechanical maintenance guys in electrical maintenance, but now the new trend is in electronical maintenance guys, because we need this kind of skills and are not so easy to find. In fact, the most of our customers that are industrial companies really struggle to find young people to select a join in their shop floors, in their technical department, in their engineering department. So really, one of the solutions is to find people also not coming from technical schools and try to develop internally using some academies or maybe our helps. You see at the center of the chart a heart, because really we think that not only the technical part would be the real changer of this period, but to find the right people to put inside our gigafactory. Because we have seen in the previous presentation how many is growing and how many will reach the end of stage of development by 2030. And so we have to prepare this. The other point is, for example, that in a few minutes I show you an example. There are big investments that require fast onboarding. Thousands of people that you have to have quick, ready to operate, maybe in cell manufacturing or in other kind of these industries, fast onboarding. And other point is I like very much, because sustainability is also social too. It's a social topic too, and should be an opportunity also to reskill and upskill a lot of people that maybe we lost jobs in the traditional sectors. So it's really an important topic and important challenge this kind. What we can do as a group, as a Festo, but also in collaboration with our customers. First of all, we are developing and we are targeting the needs, because it's not the same in all the industries, it's not the same in this area of battery. Testing and analyzing the skill gap from the people that we are getting on board, finding the right learning solution, maybe asynchronous e-learning, maybe training on the job, maybe a blended version of this solution, and to design a learning journey that reduce the time of onboarding and to get the right competencies that you need to reduce your OE, to have a high quality in production or in maintenance. And then also grant sustainability. We developed in these years some solution and some knowledge all over the stream, the supply chain stream of battery production. For example, when we talk about e-mobility product development, we have now available trainings about battery fundamental or specific use of cell batteries and in electric vehicles. And for maybe designers and engineers, we can deal with problem of test and simulation with different solutions. With other partners, we have developed trainings and learning program about power gear and electric drives for hybrid and generally speaking electric vehicles. But also we have modules for teaching to maintenance operator or operator for charging station. When we talk about manufacturing and production, the main target are operator in production and maintenance operators. And this in the two main areas that are electrode manufacturing and cell assembly and finishing, that needs different kind of competencies and attentions. These are only the first part of a project, the first phase of a project that forecast new topics and new, area of knowledge that we are developing according to with our customer of this sector industry. For example, I told you a few minutes in the previous chart the program of power gear and electric drives. So in this kind, the target are engineering and R&D professionals that have to deal with complexity growing. Our first attempt, we recognize in Italy that the main request for this kind of trainings are maybe not for the startups or the company that was born in this sector, but there are a lot of companies that are upgrading their product portfolio, that maybe have a team that is very skilled, but they don't have enough time to transfer this knowledge to the other teams of traditional products. And so they are asking for help for this. And this is, as I told before, in traditional way of the trainings or virtual classroom or also e-learning application. Okay, we have told about the Gigafactory. I want to share with you this kind of project. We are involved in a project phase for a North Europe Gigafactory that asked us to prepare with them an onboarding training for almost 1,000, 2,000 people. We are helping them in finding a program of assessment in the phase of hiring, especially in the topics of total productive maintenance and maintenance skills and competence for the operators. Then the training path plan to have a second step that is introduction to battery manufacturing problems and skills. That is around 40 hours of training, even in a blended solution, not some in training on the job, other in learning, e-learning, and other in a traditional virtual classroom or face-to-face trainings. Then, since Festo is an automation company, there is another block module that is about the technology you have on board in equipment, and so electromechanical, PLC, pneumatics, hydraulics, if you have, I don't think in this solution, but only to have a gist, the equipment technology, and then the test center to certify and grant that the people are able to take care about the new solution and able to enroll, to be enrolled actively in the production. Okay, so I hope these examples could be, I can say, an idea or a core option also to think. I have heard a lot of possibility of expansion during this day, companies that are trying to expand factories to hire new people, and I see that especially in Italy there is no time to train, no time to share our knowledge. So, okay, if you want, we could be here for help. Thank you very much to you.
Thank you very much, Alessandro. Very, very interesting.
Good evening to all. Thank you for introducing me. It's a pleasure to conclude such a long day, interesting day. I will try to make it short, leaving to you some strong message from our business, which is the aluminum casting business. We heard a lot about batteries and control of batteries, but we have a few examples. One of those was given this afternoon regarding the housing of such batteries, the containment in which batteries have to be installed in. And in our core business, which is aluminum foundries, we see for the future, with the evolution of the electric vehicle production, losses in the traditional component that we used to produce, like cylinder block, cylinder head of internal combustion engine, which are the core business for us. And preparing the ground for the future, we have to involve and develop our technology for making components that are on the future vehicle. And one of those are, of course, the battery housing, together with the electric motors. And this is what we are dealing with in developing the concept that could be useful for the electric vehicle in the future and provide business to our core business. Just to give you a quick information regarding aluminum, we heard a lot about the sustainability in batteries and cell and the selection of material for those, but very few of our engineering community are talking about the aluminum that could be the material for lightweight proposal and solution selected for making housing. If we go with, let's say, the experience of internal combustion engines many years ago, the aluminum came on board for making cylinder head instead of cast iron. And the engineer at that time selected the most perfect material they could have, primary alloys. They didn't want to lose or risk anything. The best choice was to have the primary alloys, not the secondary or recycled one, because they were concerned about the properties of such metal. The same is happening today in the choice for material in the battery housing. There is a concern, they want to be safe, they want to be sure that the properties are there and that the corrosion behavior is granted, and so the primary alloys is very often the primary choice for that. Problem is that if you go to this information, the energy to produce 1 kilogram of aluminum primary is very high, 15 kilowatt hour, compared to the 0.8 kilowatt hour to produce a secondary metal. So with that, the consequences are in the carbon emission to produce aluminum, and so what we have put in the title, carbon footprint, we want to keep it low. And to keep it low, the secondary alloy is the choice in the aluminum business. For doing that, it's important to consider that also the high-pressure die casting technology, which is the fastest high-volume production technology to make aluminum casting, can contribute to the development of, let's say, structural parts or battery assembly. And we have to learn more about the properties of secondary aluminum alloys that in this process can be used and can be, supporting the evolution of the business in the direction of low carbon footprint. One good example of this approach, of course, as given, I will not spend too much time because our colleague from Mainz already introduced such a huge project in Europe, European base, IPCI. We are involved in the battery system as endurance company in this project, and we are working from the beginning. It is crucial to do it together with the cell producer, the designer of the system, and the designer of the assembly line to make products. Only with that we can somehow take advantage of all the benefit of our technology combined with the others. And this effort is very important to be in because we are learning a lot, looking at what OEMs are already doing. One example, the most important in Europe for a European car maker that is making the battery pack in the primary aluminum alloys, give us an idea of where we could change materials and technology and to change the way the product is designed, keeping in mind that we want maybe to recycle separately what is the cell and what is the aluminum. Or we want to access for manufacturing or repurposing some of the cell that are used inside modules. In this case, you see that the complexity of such a battery housing is made to have place for modules. And we are concentrating our first effort on the modules themselves. So what we have done, and I'm showing this in these slides, is to first of all taking those modules and understanding how they are assembled. Today, those are LG Chem provided or SK Innovation provided to VW, Volkswagen, and the solution is totally against disassembly for repurposing or for recycling separately the material. They have decided to make a solid one-piece unit that is laser welded, and there is no way to take out cell without destroying those. Could be, I'm sure, the reasoning behind justifies such an approach, but from our point of view, for the sustainability in the future, we don't like it. Personally, I don't like it. And with the team, we are trying to develop something that opens the possibility to avoid what we can see in this movie, that I'm sure it will work. He told me, 1 second, because this...
Help is coming.
Yeah, help is coming, and this is, yeah, thank you. Okay, maybe you have already seen how in Germany Volkswagen is handling those modules at the end of life. Start. This is a full module that will be recycled, but assembled by laser welding and closed inside. This is what is happening for recycling such a component. If I look to this and I imagine the 800 euros value of the pouch cell that are inside, meshed and crashed together with the aluminum case, I personally don't like the solution. Maybe it's the most efficient one. Again, I don't complain. I'm glad they do. But from our point of view, I believe it's better to design something different. And we have the possibility to do so.
Aren't they scared about the short circuit and explosions?
I answer to you, if you are interested, on the YouTube there is the complete movie. And they spend half an hour mostly to discharge completely the pack and discharge completely the module before they charge the crashing line. So it takes some time to take also this. And in this approach we are considering also this disassembly, which is not, in our new concept that we are developing within the IPCI in our activities.
Okay.
Yep. To approach correctly this development, of course, we need to consider all what is requested to the housing of the battery module, and also which are the material that we can select to do the proper job, because we are moving away from extrusion, which is the solution of these modules, which has an high thermal conductivity. We learn and we know how much important it is, and we are moving to high pressure die casting, where in this slide you can see some of the alloys are providing similar to the extrusion thermal conductivity. So also the selection of the material in high pressure die casting has to be driven with these, let's say, features of the material in mind. And we are moving in such a direction, selecting the proper secondary material alloy and designing the concept with the possibility to open it. Of course, we have to also understand which are the limits of the technology. Doing a casting in such a narrow space, we have the limitation of draft angles that we have to put in the mold to open and make the casting coming out of the mold. As well, we want to reach very thin wall because we want to reduce the weight of the housing. So technology also, from the manufacturing point of view, is important to handle, and as of today we have high pressure die casting machine able to cast in a range of 1.5 millimeters castings and draft angle that can be narrowed down to 0.5. In some cases this is not enough. I realize that we have to guarantee to the pouch cell some support where they don't like the draft angle, they want to stick to the wall, but also we are opening the possibility to use not only pouch cell. In the concept that you see, which is on the top right, we have a high pressure die casting envelope that will have a cover, plastic cover for the moment, but opening this cover we can introduce in the module cylindrical cell or prismatic cell, and allowing to have a module which has some sub-module or similar to those that when the possibility will be, can be reused and disassembled at the end of the first life, just in case there is an opportunity to have a second step before the recycling, or even before what we know is done already today, an energy storage for energy, alternative energy, which is a possibility to reuse the cell. It's a challenging project, but in the IPCI, the European community likes two factors in this project. One, the use of secondary aluminum alloy. Second, the possibility to open and do some maintenance or reuse of the internal cell before the final recycling. And so we are motivated to go in that direction, and we see already opportunities for cylindrical cell that can be used also in a field that is not automotive, and then we have to cover. And the example is in the hobby tool business, which is a huge one. Gardening and hobby tool, maybe you know already, is going to electric faster than automotive. And so this could be an opportunity for us to have a product that can be used in another field of application before the end. And with that, I stay in the time just to add one last comment. We have in mind also the possibility to develop modular housing, modular, let's say, component that, depending on the power and the features of the media that we want to use, can be done. And this is the first example we have already developed for a two-wheelers, in which, depending on the capacity of the battery that you want, we can combine the same two castings or three castings and provide modules that are, combined together like a Lego project. Last point, IPCI, we heard about the size of such a project. Endurance, with this idea of using aluminum, is in the first one for automotive application, but in the second IPCI we will deal with swap technology. We heard today how important swap could be, and we believe that some of the housing for these swappable batteries could be in aluminum as well, because they need to be used very often, many times, and maybe the features of the material can gain some ground versus plastic, including the recyclability of the final metal. And with that, I thank you, and the conclusion are already there for everybody if you are interested.
Thank you very much. Really, really inspiring and really, really interesting.
Thanks.
Very good.